Hi there. I wanted to go back and edit something on this PowerPoint, and apparently I can't with being stuck in recording mode. So we're just going to go with this. So for lesson 3, we are moving from functions into specific kind of function called the linear function. And this lesson is going to focus on evaluating and graphing, and we'll also talk a little bit about the domain and range, just remembering that the starting set is the domain and the ending set is the range. So a linear function specifically is a function whose mapping pattern will graph to a line. And you can see the, sure, I've got my pen on, the word line in the word linear. Okay, so that's our adjective form, and then line is our noun form. And if we graph that particular kind of mapping, we do have a pattern to it. Now, the box or bubble on the left is our domain. That is where we start. And then the bubble or box on the, I guess it's a bubble. I don't know why I want to say box. It's the kind of day I'm having. On the right is the range. And what I have here is the pattern. So the pattern is you take an element from this set here, you're going to multiply it by 3, and then add 1. So -2 times 3 is -6, and -6 plus 1 gives you -5. Therefore, the ordered pair -2, -5 will be a part of that relation. So we'll go and find that. So that would put us like right there. That's horrible. Right there. Okay, and we could repeat this. So we could have x is -1, and so -1 times 3 is -3, and -3 plus 1 is -2. And so that puts us right there in another awful looking dot there. Now, this is where it gets easier, and I do want you to pay attention to this. If it's a 0, okay, here's our pattern. 3 times 0 is 0, and 0 plus 1 is 1. And so 0 maps to 1. So that'll put us right there. Okay, 1 times 3 is 3, and 3 plus 1 is 4. So here we go. Boom. And the last one, 2 times 3 is 6, and 6 plus 1 is 7. And so that puts us up here. And you'll notice that that particular mapping pattern graphs to a line. Now, right now, it's just what we call like a set of ordered pairs. But if I were to just say like etc. here, okay, meaning you can keep on going, like keep going, keep counting lower, keep counting higher. What about 1.5? Like, could we pick 1.5? Well, it's not listed on here, but I could pick 1.5, so 1.5, plug it in here, and then I would add 1, and I would get some number like right in here, okay, in between the 1 and the 2, probably like halfway between. And what we do to fill in all those other points is we simply connect these dots. Okay. All right. So linear functions can be written in the form mx plus b. That is called slope-intercept form. It is one of 3 main forms for equations of lines. Typically, a standard function, if it were standard form, you wouldn't use function notation for it, but you can use function notation in some of the other forms. But if you're writing it as a function, it'll take that form mx plus b, which you can see right here. You've got the mx and then the plus b, which is 1. The b tells us something called the y-intercept. And right here, I want you to see it. Okay, I'm going to highlight it. Here's my plus b. Ooh, I can't find my highlighter. Where? There it is. Oh, you know why? Because I don't have it on highlight. There we go. If I can see it. All right, there's the plus 1. And I want you to come over here and look at the graph and see where it crosses the y-axis. So it crosses the y-axis right there at the 1. And then the m tells us the slope, which is the rise over the run. Now that should sound familiar from Algebra 1. So I want you to notice this, okay? So if I pick any 2 points, so I'm going to pick these 2 points right here. If I count the rise and I count the run between those points, watch this. Starting at this point, I'll count up 1, 2, 3. Make sure you're counting the spaces, not the lines, okay? You're counting how many steps you have to take. So step 1, step 2, step 3. So that one, the rise was up 3, and the run, count over, is just a 1. And notice that 3 divided by 1 is the 3. And so the first number, or I don't want to say the first number, but the number multiplying the x will give you the slope, and the number that's being added or subtracted tells you the y-intercept. All right, so how can we find the slope? I'm actually going to do this 2 different ways because I want you to have more tools in your toolbox. Too many students try to pick like this one way, like if I am asked for the slope, then I will do this, that, the other thing, okay? And I want you to have options. If you're not good at one way, can you figure it out another way? So here we have a relation. This is the same relation that we had. So this is linear. And what we're going to do is pick any 2 points. Any 2. So I could pick -2, -5, -1, -2, 0, 1, 1, 4, or 2, 7. So I'm going to go for the purposes of this video. Now in class, I'm going to let the class pick, okay, just which points do you want. For the video, I'm going to pick what I think are easiest. And for me, when I'm looking at that, I'm like, what do I think are the easiest points? Oops. I think probably those 2 points are going to be the easiest points. So I kind of think the point 0, 1 and the point 1, 4. Okay, because I think they're the smallest numbers. I don't want to deal with the negatives. So pick any 2 points. Now plot them. So the point 0, 1 is right here. And the 0.14 is right here, and then literally count the slope. Okay, so if you know slope is rise over run, you're going to count up 1, 2, 3, and you're going to say, okay, to get from one point to the other is 3, and then count the run, which is over 1, so you've got 3 here and your 1 there. And so the run is 1, therefore the slope is 3 divided by 1, or just 3. And that would work for any 2 points, okay? They don't have to be next to each other. Any 2 points. Now, the other way you can find the slope is something called the formula, and this will probably be familiar. So the formula for slope is y2 minus y1 over x2 minus x1. And then you have to just plug in the points. Now, what's important is, first of all, the subscripts on this are just telling you which point is which. So the 2 just means 0.2 and the 1 just means 0.1. So y2 means the y coordinate from 0.2, y1 means the y coordinate from 0.1, and it does not matter which point is 0.1 and 0.2 as long as you don't change your mind halfway through the problem. So I'm going to go ahead and say, let's just call this one x1 and y1. So that is 0.1, and this will be 0.2, which will make this x2 and y2. But you are welcome to do that the other way around. Just don't change your mind partway through. Y2 is 4 minus y1, which is 1, over x2, which is 1, minus x1, which is 0. 4 minus 1 is 3. 1 minus 0 is 1. And so 3 divided by 1 is 3. And that works as well. The formula is good if you've got numbers that are either like super, super big or super small, or you have like decimals, fractions, like you have really messy numbers that would not be good for you to plot on the coordinate plane. But both of those methods are legitimate ways of finding the points or finding the slope. So if you are really bad at this, like you flip the numbers around and you add wrong and your negatives screwing you up, then try this. Try counting the rise over the run. Just make sure that you're showing some work. So don't just have a 3 appear from nowhere. Show this over here. Show that you sketched it, plotted it, and counted it out. Okay, so you want to just support what you're doing. Okay, now what can we do with linear functions? Well, there's two things we're going to focus on in this lesson. One is to evaluate. And I was actually just talking with some other math teachers earlier today about stuff that they were seeing in their classes. And one of the points that came up was sometimes students don't know the direction. So when you see the word evaluate, in order to know what to do, you've got to know what that word means. So to evaluate means given an element in the domain, find the element in the range that goes with it. In other words, you've got your function, okay? You got your x, and then you have your f of x. And you are given, say, the number 5. You are being asked to find what does the 5 map to. Okay, what does that do? So as an example, we have the function f of x equals 3x plus 1. So that's telling us the relationship between the element of the domain and how we find the element in the range that goes with it. So I know that if x is equal to 5 in this case, if I want to find the element in the range that goes with it, I will take the 5, I'm going to multiply that by 3 and add 1. And so 3 times 5 is 15, and 15 plus 1 is 16. So what that means is that over there, we would have a 16, and it would also mean that the ordered pair 5, 16 is on the graph of that line. This is supposed to be a 16 up there. Okay, so this is a practice one. What will happen in class is we're going to kind of stop everything for a moment, and students are going to have a chance to do this one out on their own. Take a moment, pause the video, work it out on your own. Okay, so let's see what you did. So we have -2. We've got 2 in the domain. And we want to find out what does that map to. So we're going to do -2 times 2, which is -4. And then be careful with this. This is -4 like plus -3. So it's like -4. And so you're to the left on the number line. And then the -3 means you're going to go 3 more to the left, which is going to put you further to the left. It's going to land you at -7. If you got that one wrong, so I want you to pay attention. If you did this correctly and then got the wrong answer, that is arithmetic. That's not algebra. Just means that you might need to slow down, use a number line, or grab a calculator. Okay, that would be your solution to that if you made that mistake. Now, the other thing we can do with these is graphing. And to graph, I'm going to show it to you this way. I never used to be in favor of doing it this way until I saw just some stuff that students really struggle with. So I kind of go back to this. So to graph it, you're going to plot 2 points. And from geometry, you know that 2 points determine a line. So for a line, you don't need more than 2 points. Like you could have more than 2, but you don't need more than 2. Plot 2 points and find where the line is, and then connect them to represent all the rest of the points. So to do that, we're going to build a table. And so I have the table over there, and we have a column for x and a column for f of x. Okay, so this is, again, our domain. Our domain, and this is our range. So you have like one set and then the other set. You can almost picture like the little bubbles here, okay? And we're going to figure out what maps to what. You can pick anything in the domain that you want. So for a line, like really that's anything. Now what I see there is I see a 1/2. So the first thing I'm going to have to do is multiply by 1/2. I'm going to have to find half of the number. Any number works, but even numbers are easier to find half of. So half of 8 is 4, or half of 10 is 5, but half of 9 is 4.5, and now I have a decimal that like I don't really want. So I'm going to go ahead and pick, say, 2, and then I always like zeros. Zeros are often a very good number to pick. So what I'm doing there is I am picking 2 and 0 in my domain, and I'm looking for what they go with, and I know that they are related by 1/2 x plus 5. So half of 2 So plug in a 2. So half of 2 is 1. 1 plus 5 is 6. And then 0 is always awesome. I shouldn't say always, like that's very absolutist. Very often is awesome because 1/2 times 0 is 0, and then 0 plus 5 is 5. Okay, and so now I have found 2. You could pick others. So you could pick the number 1, you could pick the number 2, 3, 4, -1. It doesn't matter. The domain of a line is all real numbers, meaning there's nothing that's excluded from that domain. So you can go ahead and pick whatever you want. So there we go. Choose any values from the domain that you want. Find the value in the range that they map to. That's called, I didn't know where my animations were on my slide there. And then plot those ordered pairs. So here we are. So 2, 6. So here's 2, 6. And here's 0, 5 right there. And then you're going to connect those to represent all the other points that you didn't pick. Ta-da! There we go. So just pick any 2 points you want. Now, what's expected from a quick sketch? So when it says like sketch the graph of a line, some of you are probably panicking and you're like, wait a minute, I don't have graph paper. I don't have, like, I can't, I got to go to work after school. Like, what does she want me to do? Here's what I expect. So once you have your 2 points, so you don't have graph paper, you're in a hurry. Okay. Literally doing this. I'm doing this with my finger on the computer screen. Make an effort to make sure that your tick marks are sort of close together. Okay. Okay. Do have to have tick marks though. And then we have the point 1, -4. So 1, 1, 2, 4. So 1, -4. And the point -3, 1, 2, 3, -1. And then just connect them. And that is enough. So that took me way less than a minute. Okay, for a quick graph. I just need to be able to see where your points are. So you do need to have tick marks, but you don't have to bust out a ruler or anything. If we need it to be super, super, super accurate, we're going to use a graphing utility to do it. So I just need to clearly see 2 of your points and that you've connected them. So don't take a ton of time doing that. Now, are there shortcuts? Why, yes, there is a shortcut for graphing lines, and you're probably familiar with it. Instead of finding 2 points on your own, you can quickly find the y-intercept and the slope and use the slope to find the second point. So, but I will say only use this method if you understand it. Don't use this method if you really don't understand how it works. So here's the deal. With the y-intercept, you're looking for where the line crosses the y-axis, and that's where x is equal to 0. So it would be like plugging in the 0. I said earlier, 0 is a really nice number to plug in. So you go plug in the 0. -2 times 0 is 0, and 0 plus 1 is 1. And so the y-intercept is at the 1. And then we know that the slope is the rise over the run. Okay, and so we think, okay, so it's -2, and then you think, what would it have to be over? It would be over 1. And so what that tells me is that I am going to count down 2 and right 1 from the y-intercept. So you start here where you plotted the y-intercept, and to find the second point, we're going to count down 2, 1, 2, and right 1. So we're going to put it right there. And then connect them to represent all the other points. Now, that is the fastest way to graph it, but my experience has been that I've had a lot of students that can graph it that way, but if you ask them like, hey, where do these points come from, they don't know. So kind of go back to that table if you need to. All right, so that's the entire lesson. So we are coming in under 20 minutes. Here's the practice set. You're going to finish this for homework. So for 1 and 2, I want you to find the slope by plotting the points and counting. So I want you to get that off the graph. For 3 and 4, I want you to find the slope using the formula. So we want to be able to do both ways. You can check either way, the other way, if you want. For 5 through 7, do the evaluation. For 8, sketch the graph by finding 2 points on the table. And then for 9 or 10, you're free to sketch the graph however you want. All right, so I hope that helps. You guys know how to contact me if you have questions, and I'll see you in class.